first of all, like many papers, I have a long run agenda here, and just to give you the motivation here, it's not apparent from what I'm doing. It has to do with major welfare reform that occurred in the United States in 1996, which probably you're somewhat familiar with, but is a very detailed reform on which there's been a tremendous amount of work already. A major reform which introduced time limits to our major cash transfer program for the poor, work requirements, and a number of other provisions. Jim Zaliak's done a lot of work on it for sure, but many, many other people in the States have, including myself. One of the things that's lacking in that literature is very many structural models of that response. There have been maybe 3 or 4 people who tried to model it structurally. It's rather difficult actually to model work requirements and time limits. It's not that simple. The piece that I'm after in the long run here is to estimate a structural model of that reform which allows heterogeneous response. That is to say, different people respond differently to that reform. And I think that all the people who've studied this program in the United States think that's happened. And I would think Jim would probably agree with that. Different people have been affected in different ways by exactly the same kind of reform. The structural models we have now aren't really set up very well to capture that because there are common parameters in most of the parameters of those models, and usually there's some heterogeneity allowed in some places in it, but not enough, I don't think, to capture the heterogeneity we've observed in the response to that reform. Okay, so that's the long run. The short run is, the question is, how would you introduce heterogeneity in a very, very general way into a very simple structural model of the labor supply response to a welfare program? And that's what I mean by a classic transfer program here. I'm starting really simple here, which is, let's take your textbook transfer program. You have a cash transfer program. It offers a guarantee to people who don't work, and it imposes a tax rate on benefits. The classic program that you observe in undergraduate labor economics textbooks. And I want to ask, how would I introduce heterogeneity in a very, very general way into that kind of model? I haven't actually gotten that far here. What I have is a lot of reduced form results showing how if you took such a model and you estimate it in reduced form, allowing general forms of heterogeneity, what would the response look like? Are there kind of basic simple evidence of heterogeneous response in reduced form settings of a structural model? And then I have the beginnings of a structural model, which is far from complete, and I only have really kind of one result there. So I really actually have one result which is consistent in my kind of primitive structural model and my reduced form model, which I'll show you. There's a lot of, given this, there's some methodological aspects clearly here, since I haven't gotten the bottom line results that I want. So that's the background. So heterogeneity, okay, I mean, I think probably 2/3 of the papers here have mentioned that word, so everyone kind of agrees on the importance of that, whether it's only observed, but either unobserved, very popular in models across the field of economics now. I have some very old remarks here. I think it's really, econometrics been around for a long time, but I think probably a lot of you here are familiar with the literature. It began maybe about 20 years ago on introducing very, very general heterogeneity in the form of simple reduced form treatment effect models, and that's motivating a lot of what I'm doing here. And in fact, this paper is kind of an exercise in estimating marginal treatment effects, because that's the way in which I'm going to introduce very general forms heterogeneity, and I'm going to allow marginal treatment effects in response to a classic transfer program. So you have a classic transfer program, you can change the guarantee, you can change the tax rate, and different people will respond to that in different ways, and different people will change their participation rate in the program, and the kinds of people who come in or leave will have certain kinds of labor supply responses on the margin, and that will maybe be different than the labor supply responses of people who are initially in the program you start off. So you're going to get a different kind of response depending upon the composition of the people who start off. And you get a different kind of response for different kinds of reforms. In fact, what I'm really after here is really getting after this. What's the response to marginal tax and transfer programs? Different people are inflated by their marginal tax rates and income transfers. So the guarantee and the tax rate in a very general model expansion of a program, for example, by raising the guarantee or lowering the tax rate, could have very different effects on marginal treatment effects because they bring in different kinds of people in different parts of the income distribution, in different parts of the hours work distribution, and the kinds of people who respond are different. And my model will show, the model, I don't have estimates for, but will show how that would occur. It's not really that complicated. Another implication of heterogeneity, I think, and this relates to the 1996 reform, which I'll ultimately study here, is that even though you might be able to estimate by ignoring as non-parametric heterogeneity as I have here, you might be able to estimate average effects, but the heterogeneity of response implies something about the distribution of responses. And so if you want to know, let's say, how the variance of income is changed by a particular welfare reform, you need to introduce the kind of heterogeneity that will allow people to respond differently. So that's another thing that I'm after here. The idea of heterogeneous response, even though they didn't put it that way, if you go back, way back to Bertlis and Hausman, who had a classic transfer program, and they were modeling the labor supply response to it, they actually did allow heterogeneity in a very constrained kind of parametric way back at that time. And a lot of us who were working at that time, working on nonlinear budget constraints, really that was a heterogeneous response model because different people are initially situated in different parts along the budget constraint. And when you introduce a transfer program or change it, then because their initial position is differently, their marginal response is going to be different because the marginal change in the tax rate and the income effects are different. They can make some non-marginal changes, which you have to account for, and that's a important piece of it. But they really solved that problem. And so I don't have anything much to add there, except that you could take their model and be much more non-parametric of the kind of heterogeneity that they had. It was a very highly constrained form, and I'll say a little bit more about that as a way of comparison to what I'm doing. But what did they ignore, and what many of the papers in this literature ignore, is what I'm calling here the incomplete take-up problem, which is really intrinsic and necessary to my whole approach here. And if you don't buy that, then none of this really makes any sense. So the incomplete take-up problem is that, at least in the US, and I'm not going to vouch for any other program or any other countries, but it's true in most transfer programs we have for the low-income population. Not all the eligibles participate in that program. Even in this program I'm going to study here, this class transfer program, which are for single mothers, which used to be called AFTC, the participation rate of eligibles never really got up higher than like 60, 70, 80%, something like, even in the best days. If you look at the food stamp program, the participation rates of eligibles there are around 60%, something like that. And so you don't have everybody participating in the program. So aside from the policy issues the modeling issue is that how do you model that? Because if you just take the budget constraint and assume everyone's on the boundary of their budget constraint, the data don't support that. There are a lot of people who are not. Yeah.
So is the issue that it's means tested, or yesterday it came up, for example, the unemployment insurance take-up rate?
Yeah.
For the low income seems to be low, or is it information, or is it some other?
Well, the low-income for UI, low-income population, is a complicated one because, first of all, some of them aren't even eligible because they haven't worked enough in the past year to actually qualify because you have to have a minimum number of weeks and minimum earnings. And then they come in, and why they don't take it up, well, there could be many reasons. And one is that cash will be taxed by another transfer program if they want to do it. Another problem is that a lot of people don't take up UI if they think they're going to have a short spell because of the transaction cost of going down and complying with their work requirements and all that. So it's a related problem. I think in UI there are some good explanations for it, but in these other programs I'm talking about here, it's actually been difficult to come up with a credible, at least empirically validated reason that people don't do this. In my paper back a long time ago, I kind of threw out this idea that at that time only sociologists had, and economists have jumped on it, with this stigma, that you don't want to be a welfare recipient either because you perceive it yourself, your own self-worth depends upon whether you're a welfare recipient, or because of perceived effects from other members of the community, and they might see it. That actually leads into the economics literature today on social interactions and group effects. And Tim Besley and Steve Coe did a paper on that a long time ago, on how you can have multiple equilibria where almost everybody in the neighborhood is on welfare because they see that now as the norm, and they're influenced by other people, and other equilibria where almost nobody's on welfare because they see that nobody else is, and I don't want to be on either. I actually believe that's very important, actually, in the current U.S. situation. But there are other reasons people might not take it up. One is they may not know. There's an information problem. They don't know that they're eligible. The rules of these programs can be rather complicated, so information may be a big problem. Another problem is that there are very high costs of participating in these programs. They go through the application procedures, and these programs are very monitor heavy, okay? You have to come back in periodically to get recertified. They'll demand all kinds of verification of your income. You have to continually comply with this. If you're a single mother, you have to comply with child support requirements. You've got to give them the name of all the men you slept with, and you have to agree to sign court orders to go after those men. So heavy transactions costs. You may say it's not worth it, okay, to do this. And I say it hasn't really been, it's very hard to prove, distinguish these explanations, and we don't have good data on the cost. Having said that, I'm going to come up with a variable here for costs, okay, which you can laugh at. But I'm going to argue I have a variable for it. So anyway, so that's really important here, because if you don't have incomplete take-up, if everybody's on the budget constraint, then participation in the welfare program is not a choice, and not an independent choice. You just choose where you are along the budget constraint, and that's the Bertelsmann and Hausman. They solved that problem. If you have a constraint, how do you model your choice of where you're going to be on the program, off the program, and how is that affected by the parameters? But the whole treatment effect issue that I'm bringing here only arises if you have incomplete take-up. I actually believe that if the Bertelsmann and Hausman's approach is actually, I'll go stronger and say their estimates are biased and inconsistent if you do have incomplete take-up. Because if you assume that everybody's on the budget constraint, and what you're basically doing is just modeling the labor supply response to a change in the guarantee and the tax rate, what's happening is if some people change their participation as a result of those changes in the guarantee and the tax rate, you're not estimating just the income substitution elasticities of a given utility function. You're confounding the responses that are coming from a given utility function with the responses that come from changes in participation as people move in and out the program. And if the kinds of labor supply changes they have are affected by those guaranteed tax rates, you're not separating the two. And my model will just show kind of a very obvious way why that problem would arise. My paper a long time ago with Mike Keene is one of the models. Actually, this paper did that, but this was a little bit cleaner approach to really where you have separation between take-up and response of labor supply conditional upon take-up. Two-equation model, basically, although we had multiple programs there. So, and in fact, some of what I'm going to do here, when I get to a structural model, basically I'm going to take my paper with Mike and just kind of say, okay, suppose that were the utility function, and I want to introduce heterogeneity into that one, because we didn't have very much. We had very simple kinds of Bertelsmann and Hausman heterogeneity that we had take-up, but in the labor supply function, just kind of additive heterogeneity, it was very simple. And I'm trying to go way beyond that in terms of heterogeneity here. So anyway, okay, so versus steps. So I'm going to try to do the following. Introduce incomplete take-up, be somewhat non-parametric. I don't want to claim to be completely non-parametric here. And I'm focusing on the identification estimation of marginal treatment effects in a structural labor supply model. And just it's going to be a static labor supply model. And I have a beginning on a structural model work in progress. Okay, so so here's some intuition. So here's the model. Actually, this is not quite what Bertelsmann and Hausman did, but I did this kind of model. A lot of people did this kind of model, where you you're estimating labor supply response to a transfer program. You have, let's say, this is a linear labor supply function, which I'm not going to use, but that's, the intuition is all here, which is that you have a heterogeneous intercept. So different people have different utility functions, and they start off at different places up and down the budget constraint with different hours of work. And then they're faced with a net wage and a non-labor income depending upon P, which is going to be my dummy variable for whether or not you're on welfare. So if you're on welfare, you're going to have a W times 1 minus T here. You're going to have a guarantee. If you're off welfare, you'll just have whatever wage and non-labor income you'll have if you're from your private sources. And so the slope of the budget constraint will depend upon whether you're on welfare or not. But the only heterogeneity is in the level. And you get nonlinear response, and heterogeneous response is from that. Because as I said, if you start off way off, a high income per high hours of work person, you're very far away. You're going to respond differently than you start off being at a low. Your difference curve puts you way down below and in the eligible region. But still, this would be obviously a more general case where you have heterogeneous coefficients on the net wage and non-labor income, and that's more what I'm after, doing that. And then when you do that, and this is all kind of an example of the treatment effects literature, that's a different kind of problem, because now you not only have that participation in the program is related to where you are. For example, if you start off with a high alpha, you're unlikely to participate. If you start with a low alpha, you're more likely to participate. But here, your participation may depend upon beta and gamma. So it's not as conventional random effects regression equation, because the endogenous variables are correlated with the random coefficients. So this is what I'm after here, even though I'm not going to use the...
Just on that, I mean, the irregular treatment effects doesn't have a wage or anything like that. So,
right.
You can get, the heterogeneity will come through the wage even in the first model there in response to...
Oh, yeah, that's right. That's right. You can have, you can do...
About the model that,
there are the channels there, yeah.
You shouldn't do that, but even the standard model has
it does have some header there. It does have an effect there, yeah, through the wage. So, or whatever the budget constraint. Yeah. So, what I'm trying to do here is take that marginal treatment effects literature and say, okay, let's try to do a little bit more of a structural model here, and introduce that instead of most treatment, marginal treatment effects literature is pretty much reduced form, okay? But there's nothing in principle that says you can't introduce the concepts that are in the treatment effects literature into structural models. There's absolutely no reason not to, and that's kind of another underlying goal I have here. So as I said back in the beginning. Okay, so so if you have this kind of problems, I say the question you have is, if you start changing participation in the population, say you change the guarantee or the tax rate, the marginal treatment effect question is, if I bring some more people in, are they people who have betas which are higher or lower than the people who were there initially? Or if I bring people in, do they have higher or lower gammas than the people who were in the program initially? That's the marginal treatment effect question, but rephrased in terms of a slightly more structural model. And that's what I want to do, is just find that out. I also going to have a little bit here on whether there's anything predictable about that, whether as you expand the program, whether you would bring in people who have greater or labor supply responses, or the people who enter the program beginning, the people who have the really big changes in H, or the people with the really smaller changes in H, and as you expand and maybe go to the full population, how do those labor supply responses change? So, so that's phrased here. Are those who moved in and off of the program out to reform have responses greater or smaller than those who are stayed off? Okay, so the connection to the marginal treatment effects literature here is my non-parametric piece of this. Is I'm just going to take straightforward the approach in that literature, which is to say that I'm going to have some instruments which move participation around independently of labor supply. And, but my instruments are only going to sweep out a certain range of participation rates. And I'm not going to have instruments which have almost nobody on welfare with P of 0, and I'm not going to have instruments which give me populations which have P of 1 where everybody's on. So I'm not going to be able to get the whole range. I can only figure out the marginal treatment effects over the range of participation rates that my instruments give me, and I'll show what that is in my data, and that's what I'll estimate. And my goal here is to be non-parametric on who's brought in. And I'm going to be completely non-metric on that curve is on whether those marginal labor responses are greater or smaller than those of the people who are on initially once you expand or contract or expand the programs, I guess is what I'm talking about. Okay, so the formula model, here, let me lay out one just to fix your ideas here. So here's a very typical way to portray this problem. So you've got a utility function for the hours of work, income. You have a vector of taste parameter theta, which are unique to the individual I. And then you've got this way of capturing incomplete take-up. And there are different ways to do this, and because we can't really identify them separately, this is the most, I would say, the most common way, which is to say that if you participate, there's some fixed cost, I'll call here, phi, and it's unique to I, so that has to be heterogeneous here too. If that were the same for everybody, it wouldn't be a very interesting problem. So people differ in those fixed costs, and I'm going to treat those in mostly unobservable, but I am going to come up with some observables for that. And as you're going to see, this thing is going to play the role of the instrument here, because it's going to move participation around, holding everything else fixed over here. Now, this is just a separable form. You can interact these. It gets more complicated, but there's nothing conceptually difficult about doing that.
Will you have the time-varying heterogeneity, like health, for example?
I'm not going to have health in here. I'm going to do a completely cross-sectional model here, and I'm going to have some, exogenous covariance. I don't have health in there. I don't know why I have health. I should add, my data would certainly have health. So I'm going to have standard covariance here for, education, age, race, children, all this, the usual kind of suspects. But I should add health because that would be effect here. So you've got a benefit formula. Here's your B, and your benefits determined by a guarantee, and you get your earnings and your non-labor income taxed away. You've got a budget constraint. If you're off the program, your income is just equal to your earnings plus your earned income. If you're on the program, your earnings are taxed at little rate T. Your non-labor income is the guarantee plus the non-taxed portion of your non-labor income. That's if you're on. So you've got two constraints, and then this is the kind of labor supply function that you get out of this, which is also very well known among people who work in this literature. So nothing new here. But I'm writing it in general form, that's all. And the hours work function is a function of your net wage and your non-labor income. It's a function of whether you're on off welfare. So I'm using a dummy to just collapse those two categories of labor supply into one equation. And there's a vector of taste parameter theta. And then whether you're on the program can be portrayed as the difference in the two indirect utility functions. Utility if you're on minus utility you're off, so that's the utility gain. Minus the fixed costs, okay? So what the idea here is you compare the utility gain of the usual kind, which is I gain consumption and I gain leisure in some kind of combination, and I make that calculation, then I look at the fixed costs and subtract that off and say, am I gonna participate or not? And that's what determines my decision. So this is an equation here, and you could, you can think about, well, I'm going to try to estimate this thing. And I'm going to allow theta to be some non-parametric distribution. I'm going to allow, a phi to have some, non-parametric distribution. Why not allow them to covary, which I think is very important here, that the fixed costs might vary with your taste for labor supply. And that's what I'm after, and I haven't done yet. So, but the idea is pretty simple. So here's the diagram, which is very familiar. I just want to point out, as I said verbally, but you've got people in the data who are down here, okay, who aren't on the program. They could get a benefit and they're not. And you can't just ignore that and assume everybody's up here. Or your estimates won't be right. For your estimates of income and substitution elasticities of the parameters of the labor supply function. So anyway, I'll come back to this diagram in a second. So, so there's a lot of algebra here, which is not all that interesting. But it leads into the marginal treatment effect in this kind of context, which is to say that the effect of a program, which is delta, the effect on labor supply for individual I depends on theta, obviously their preferences, and so it's the difference in hours of work. Of course, we're never going to be able to estimate the labor supply change for an individual. All we can do is estimate means over a particular population. So The mean of the change for the whole population here is the mean of this thing, conditional mean of delta times p. So this is the whole of the population. So some people have p of 0 and others have p of 1. So it's a weighted average, basically. And that's just the integral of all the individuals over these unobserved components here over the ranges of the distribution where they would participate. So, but that's the mean over everybody. So if you want to know what's the effect of the mean labor supply response of the people who actually choose to participate, you should divide that by P. That's called the effect of the treatment on the treated in this literature for what that's worth. So, what about the marginal treatment effect? Here, it's this. You look at you figure out, if you can figure out this thing, which is the change in the hours of work. Suppose you change the guarantee or something. You take the whole population, people who are on off welfare, you observe that mean changes. You know that that change in the overall mean only arose because some fraction changed their labor supply. Then you just back out what the change in labor supply of the people who participate by just dividing by the participation rate, because you're assuming that's the only reason H changed. So anyway, this is all pretty well known.
Robert,
Yeah.
could you go back a couple of slides to your graph?
To the graph? Yeah.
So I guess there's no reason why you couldn't include the people who are down at that 0, right? So they're disconnected, right? Who choose not to work or to join the program. Would they be in your?
You can have people down here, yeah.
Yeah. Okay. So
Yeah,
there's no
they must have
reason why.
really strong taste, fixed costs or something, because they've got a big welfare gain, you know.
You have to get the wage rate for them as well, which is another.
Oh yeah, no, this is, you know,
We know.
you can do that the same way everybody does it, so, but,
I mean, depending on, who you believe, right? There's a lot of people at that 0 right now.
well, you know, you can do the following. You can kind of estimate people's wage rate, you know, their budget constraints here, and look at the data, and you can say, you know, what are the participation, the take-up rates, you know, up at different levels here, and you find that the take-up rates are higher down here, you know. Now that's just a reflection you've got a higher gain, you know, the benefit, I mean, is higher down there, okay? It's not because of higher fixed cost of work, but you know, I mean, it's a different thing, but it's not surprising that take-up rates are higher down here than, you know, up here. And
Though in your discussion, the information, you know, if it was just an information problem, it's unlikely you'd get that.
you could,
That's why the stigma thing seems a little more convincing.
yeah, no, the information.
There's quite a strong correlation between benefit gain and participation.
Yeah, and you can just regress, you know, run the participation regression on the gain, estimate the gain, and it's all, I mean, you get huge, you know, positive impact of the gain, of benefit, the monetary gain on the take-up rate. Yeah, for sure.
What if you're on disability? Will you appear at 0?
What's this? The model here, you're worried about the model? Because I assumed there was no corner solutions in the model I
No,
wrote
because
down.
I think you suggested that there are some people who at 0. But
Right,
I'm saying
yeah.
Who don't
0
participate.
doesn't
There are
mean
some.
0, or could they be getting, say, disability, but they are not in a means-tested program,
They could be getting disability.
which will limit the number of hours that they can work.
Oh yeah, no, if you're receiving some other program, which has basically work requirements or implicit work requirements, like a disability program, well, you can't work, and you can't receive it. I mean, basically, they could be down here. Yeah, I don't think in the data I've tried to throw them out. I've thrown out people who receive just DI benefit, SSI or DI benefits. They're out of the data. I haven't gotten a variable, you know, for disability or health in here. So yeah, no, you're right. They could be there. But no, with this take up, even if you take healthy, I'm going to look at single mothers here. The vast majority are not disabled and they're not receiving disability programs, and still the take-up rate, including a few down here, which is weird, I admit. There has to be something funny going on. Now maybe it's unobservable, you know. I mean, DI is just one thing we don't have necessarily. There may be something else they're getting, or you know, some other source of income. I mean, there's lots of data measurement problems here. Okay, so I only make one point here, which is that I want to look at the marginal treatment effect. And what I want to look at is not a change in the guarantee or tax rate, the change in the budget constraint up here, and ask how take-up changes in response to that. Because that's, like I said, that's a change in the monetary gain. I want to hold the budget constraint constant, and I want to ask, suppose you have an exogenous change in participation, all right? And in this model, here, there's only one place, you could have an exogenous change in participation, and that's this. I'm going to imagine there's a change in the fixed costs. And that will mean that on this diagram here, wrong way. Okay, nothing changed in the constraint. I probably should have drawn some like imaginary lower constraint here to show your utility gain after subtracting the fixed cost off. But suppose I have a reduction in fixed cost. Some people like this person now decide, yeah, I'm going to move up here and go on. This person might, and some of these people might. By the way, these people up here, if you have a changing fixed cost, well, they might decide to come down too. So you're going to have responses from all over the place. And the question is, when that occurs, are the people who come on going to have greater labor supply reductions than the people who are initially on? And for example, if this person went to from I to I prime, you can see the reduction in H there. Is that reduction in H the same as the reduction in H that occurred, let's say, when I first introduced the program and some people were on already? And what I show is, although very elementary, is that there's actually no reason that it could come out one way or the other. As you bring more people on, the issue is, do people value on the margin consumption more than leisure? And if somebody's coming on, the people coming on the program really value the consumption, so let's say they're going to come up here and kind of keep their hours of work fixed and take all the gain in terms of income, then those are people going to not reduce their labor supply very much. But if the people who come on are the people who value leisure more, then they're going to be the people who really reduce a lot and change their labor supply a great deal and not take the gain in the form of consumption as much as other people. So it all depends on the marginal utilities of consumption versus leisure for the people who are coming onto the program. So it's theoretically ambiguous. I don't know the answer to that. So that leads to the empirical work, which is what I'm after here. Okay, so that's what all this is. Just saying that. And I should note here that a reduced form approach in which you don't have any change in fixed costs isn't going to work. For example, if you use a change in the generosity of the program, an increase in G or reduction in T, that's going to have an effect on labor supply, but that confounds two things. That confounds the effective labor supply of people who are initially on the program, because they're all going to respond. And then you also have changes in participation. I mentioned that before. So you need some other variable here which affects participation. So that's what I'm going to use here. The change in fixed costs, it changes participation. But under my orthogonal independence assumptions here, but in principle, in theory, if fixed costs change and the budget constraint doesn't change, then you can identify this model and get some marginal treatment. Okay, so a reduced form says, yeah.
But just in terms of changing G, I mean, I guess that still gives us the treatment effect on, or I guess an average treatment effect.
Oh yeah, see, the reduced form people will be fine. I mean, they don't care, okay? That's the point.
You're just saying we're going deeper.
I'm going deeper than that. Yeah, definitely going much deeper. Absolutely. I want to do a lot more than what they do. The model here, so the first thing I do is reduced form. So what's the reduced form? The reduced form says H is a function of W in G in, let's hold R, little t fixed, and some thetas, which has some observable and unobservable. The reduced form of this has all those budget constraint variables in there, and it has P in it, okay? So that's the reduced form. Okay, it's consistent, in other words, with the model. It's just that I'm not trying to identify, the structural parameters here of this H function. I'm not trying to my income and substitution elasticities. I'm just reduced form. And likewise, this thing is a function of the same variables. I can do a reduced form of that. So that's what I mean by reduced form. And then the structural form will be which I'm still working on, is estimating this model and getting actually the parameter, structural parameters of the utility function out of it. So I haven't.
What do you assume about it? Because the structural model wouldn't necessarily give you a continuous differentiable.
No. So when I'm going to get the empirical work, I'm going to do what everybody else does, which is assume hours of work are discrete, and I'm going to take directed. Is that what your word? Yeah. And so this is not quite what I'm. Yeah. This is just so anyway. So okay. So the reduced form is that. So here's just to fix ideas, the most basic model with what I would call maximum heterogeneity, where every response is different for every person in the whole population. So let's get rid of all the x's, okay, and just condition upon those implicitly. Each person has hours of work. If they're off the program, it's some beta, so there's a distribution of those in the population. If you go onto the program, you change your labor supply by alpha, there's a distribution of those. There's probably a joint distribution here. Every individual has a different change, okay? So that's the model I have in mind. Participation, completely, I'm going to assume a function not indexed by I here, but I'll just assume there's some unknown distribution of deltas. Z are my instruments for fixed costs, which I'm going to come and tell you about in a second. So there's a participation equation with completely unrestricted delta. Then in response to a change in fixed cost, everybody has their own individual response. Now this is set up as an index function, so that the usual way that generates a dichotomous participation dummy. So so let's talk about estimating this and what you can estimate. And here I'm just drawing on the treatment effects literature. There's really nothing new here, except that I express it a little bit differently than all those guys do. So so what I want to do here is what the conventional way in the treatment effects literature is come up with some IV, two-stage least squares or IV, and estimate this thing, and you figure out what, how to interpret the coefficient on that, and it turns out to be this late, that Emmons and Angers first came up with, and that's just a discrete version of the MT, but that's not what I'm going to do here. I'm going to take the reduced form and condition it upon P, okay? So that's a condition on Z. So the reduced form here, in my terminology, is the conditional mean of H, conditional upon a value of the fixed cost, let's say, is the conditional mean of the intercept for that individual, and the conditional mean of this thing, which is the conditional mean of alpha times P, if you remember. But I'm going to factor that, iterated expectations to the conditional mean of the alpha conditional upon P times the conditional mean of P, conditional upon Z. Okay, so that's, just algebra. So what do you have here? That the mean of H is going to be a function of the mean response of the people who participate, weighted by the fraction of the people who do participate for each value of Z. And then I can just take the conditional mean of the P variable. So I have two equations here. And what do I need for identification to estimate the model? Well, you need two independence assumptions. I don't need independent assumptions here. I need conditional mean independence, which is to say the instruments have to be conditionally independent of the mean of beta, so that this thing is just a constant. So as I move the instrument around, the labor supply of people who aren't on the program is not affected by the instruments. But I also need that the instrument does not affect the conditional mean of the response of the people who go onto the program, which would somehow say if that were true, then the instruments would be changing the preference. They correlate with the preferences of the people in the population, correlate with the response, which would completely muck up the instrument. What you would need for this is for the instrument just to affect the probability of participation, and then for the uniform effect of participation on the conditional mean of alpha. So that's what I've written down here. Here are the two, you need two, because you have two parameters. You need two conditional mean assumptions to identify the model. The beta assumption, and I need that the conditional mean of alpha, the treatment of the treated, of the people who participate is independent of Z, rather to say it only works through the effect on participation. So once you do that and you plug it back into the equation, what you get is the basic idea here, the way I'm going to estimate all these models and reduce, even the structural model I'm going to estimate in this way, which is the following. If you plug that in, did I have used that word G? Yeah, the letter G, the conditional mean of alpha, the mean response of the people who participate is some unknown function g. Okay, so I'm saying as I move participation around, what's that mean labor supply response change? So if I increase participation, does that mean go up or go down? And the marginal treatment effect is just a change in that thing. And I'm going to let that be a completely non-parametric function and just let the data tell me whether or not, as I move participation around, whether or not the labor supply change goes up or goes down. Okay, so the non-parametric part is non-parametric on G. Okay, so and here's the way to estimate that in an incredibly simple way, which is that G of alpha, which is the conditional mean of alpha for the participants, weighted by the fraction of the population who participate, plus a constant term, again, no x's here yet, is equal to the overall mean of H in the population. And I've just added error terms here because this is a conditional mean function and these things are zero by construction. So, and then I could do the same thing with the participation equation. So what does this say? All you have to do to determine the marginal treatment effects is to run this regression. And now you have to have some f's here. And what I'm going to do is I'm going to estimate f from this participation equation, the probability of participation, a function of z's. And then I'm going to use that in this function, but I'm going to use it non-parametrically. The indication in the data of marginal treatment effects is if the g here is in fact a function of f. If this is a constant, it says that as participation goes up, the mean of the whole population goes up at a constant proportional rate, which is just to say that the people who are being added onto the program have exactly the labor supply responses that people are already in. It only changes the weighted average of H in the population. But if this deviates from linearity, if this is not constant, if this coefficient on the participation is a function of the participation rate itself, that's an indication that as participation changes, the people who brought in are different. You can find this equation like in one line of one of Jim Heckman's papers, and that it's hard to be original when somebody like him is working on this. But he doesn't use this for estimation, which I will. Okay, so the marginal treatment effect, by the way, I say if you remember, just the derivative of it with respect to z. Oh, sorry, with respect to f. So I'll show that. Okay, so anyway, a bunch here on identification. Okay, I wanted some x's, so I'm just going to modify this. So the probability of participation has x's in it, so that means the probability of participation will have x's everywhere in it. I'm going to add x's here, which is simply to say that as participation changes, the effect on labor supply may depend upon observables, which is kind of, a lot of people do that anyway. That's just saying, well, people with high education or older, they have a different labor supply response than people who, have different values of those variables, and but it turns out that's pretty important. That's going to be very significant interactions here, and then x in the linear term too here. Okay, so how do I want to do the non-parametrics here? Well, there's lots of ways to do, approximate a function. Kernel methods are a little difficult here. I'm going to use splines, which is a series function method, which is very common in the function approximation literature. And if you read that literature, I don't know how many people are familiar with the spline literature, but the universal, near universal choice are called cubic splines, and I'm going to use a variation of that called natural cubic splines. They're basically polynomials in a cubic to approximate a function. And there are some issues with polynomials, if anybody's ever done that, where they kind of go off into weird regions. So I'll have to deal with that. But anyway, yeah.
And Mark, if you just go back a couple slides, just make sure that I'm kind of on the same page. Okay, so just in terms of the x lambda plus g, this is basically a control function.
Control function? No, I wouldn't.
Sorry, I'm just being slow in terms of kind of how we want to think about this G bit here.
Yeah.
I guess I'm just being slow. So I guess the identification, it's just kind of for H versus the Z's. I'm just still trying to think through the G of F versus the F.
all I'm going to do here is,
Yeah.
so I'm going to run this thing and get an F hat here,
Yeah.
okay?
Yeah.
If I don't have G in here, I'm just going to run OLS.
Yep.
OLS of H on X, some X's, and that predicted probability.
Yep.
I'm also going to interact it with X. I'm going to interact that predicted probability with X. So if I see if the coefficient on X varies by your age and education and so on.
Yep.
But then I'm also going to put in an approximation, very flexible form function here of F, of participation, right in here,
Yep.
to see if that the effect of F on H varies with if it's nonlinear, you know, if the
Yeah.
effect varies, that's all it is. There's nothing more than
Yeah.
that, okay? So, you know, notation may be a little difficult, but the idea is really simple, okay?
So the key is it's Z here, isn't it? As well.
Oh yeah, you gotta have Z. So, okay, no, so I want to have an application here, and the problem, yeah, real quick.
Okay, so you said there's no forbidden regression problem here, and that's because with H, your parameters are linear, right? Basically,
It is linear. It's going to be linear in the parameters,
Okay.
and I could say more about the forbidden, you know, relationship to this. Some people ask me about that. That's why I put the bullet in here, and I don't have the problem. Is basically anyway. My problem with doing an application of this is the U.S. doesn't have any classic transfer programs anymore, and it hasn't had any for 25 years. So so I have to go back 25 years to find a program in the U.S. that was of this form. They started reforming the program. Actually, I talked about that in the 1990s, and since early 1992. We don't have one, okay? We have in-kind transfer programs like food stamps, but that's in-kind. I just want a cash program, so I have to go back. I'm going to go back, okay, to 1989, you know, and have a little historical paper here. So, but it's, you know, I'm trying to illustrate a method. So I go back. I'm using data from 3 years, some data set called the Survey Income Program Participation. It's pretty good on measuring you know, all the variables I want, participation. Only single mothers, I take ones with low education, mid-range here. And this is the name of the program back then. The G is going to vary. I'm sorry to say that in 1989 and 1991, the tax rate was at 100% in this program. It was 1.0. And I could tell you about the history of this. I mean, it's just crazy. They lowered the tax rate back in 1967. Ronald Reagan came in 1981. He raised the tax rate back up to 100%. And in 1996, a lot of states have lowered it back to about 50% or around that. But in this whole region, from 1981 to like 1996, it was 100%. So, you know, I can tell you about the political economy of that sometime, but why Republicans increased the marginal tax rate, you know, to 100%. Anyway, I've got about 5,000 people. The participation rate on the AFTC is about 31%. About a third of them are on. Okay, so here are the instruments. Okay, so so it turned out that in this period, actually. Okay, it's always been the case in the U.S. So this program is a state-level program, so it's run by the states, but it's authorized by federal legislation. So Congress, you know, passes a law that creates the program and allows states to run it, and they had to run it. It's still true that the feds regulate the program. So the states have flexibility to set certain parameters, but they also have to have certain kinds of parameters that they have to obey nationwide. Okay, so back in this period. The federal government allowed the states to set their own guarantee. So this can go all over the block. So if Alabama wants to pay $10 a month and New York State $1,000, fine, you know. And so we have this huge cross-sectional variation. However, the eligibility conditions, how you had to count income, how you had to count assets, were all federally determined. Okay, there was very little state flexibility to do that. What the feds did then was they sent in these auditors all the time to check to make sure that the states were doing what they were supposed to do. And if you read the literature back then, it turned out that when the feds went in and did these audits, there was a huge variation in so-called error rates with people who were eligible who were being denied participation in the program. And back at the time, most people thought this was not an accident. You know, this was like on purpose, okay? Keep people off. And the feds would go in. If they found these errors, they would, assess penalties. And then, the state said, okay, well, we'll clean up our act. Let's have a negotiation here. And they ended up never paying any penalties, in the end. But nevertheless, what I've got data on are the error rates in eligibility, okay, and by state. And there's a huge variation, in these things. So I've got 3 of them here. The state eligibility error rate resulting in denial of eligibility. So what fraction of the cases that were applications to the program were just wrong? They said no, but they were eligible.
The characteristics of cases?
Sorry?
Do you know the characteristics of cases?
No.
Or is it an aggregate number?
I just have a table, table. Here are the error rates, by state in that year. I would love to know because you'd like to know, what it was. And okay. This one was always talked about. Okay, if you don't want people to come onto your program, you just give them a 50-page, document to fill out, written in English, which requires a college education to understand, and they can't fill it out, And so these are okay. I'm going to claim only so far here about this, but one of the categories in the audit was the reason. They gave reason for denial of eligibility. Okay, they did have that, and one of them was, income was too high. Well, that's fine. If your income's too high, that was a correct one. That was not an error. So, but the reason for the errors were this is the total. This one is the reason they gave paperwork. The people didn't. And this is kind of the vaguest one, which is administrative costs. How much, effort you put in, how much the welfare department spends to try to figure out the details of these cases. Because it's complicated enough that you actually need a lot of people to deal with it. And some states didn't want to spend any money on it, so they're going to make a lot of mistakes, okay? So if you run the participation probate, and everybody lives in a different state, you throw these variables in, then the more they spent, the lower the participation rate, the more that were denied because of incorrect, because of paperwork, the lower the participation, probability of participation, and the more eligibility rate, errors, just in general denied eligibility was negative. So in other words, they're all significant and they're kind of going a plausible direction. So that's what I'm going to do. And the danger here is that states that were doing this were states which had, that it was correlated with labor supply or income of the population. In other words, they're endogenous. That's the econometric way of expressing the problem. And I don't have any. So okay. So here's the data. So the first thing I do is run the first stage. You've got participation probates here. Here's the histogram in this data. The modal is people about who have a participation rate, predicted probabilities of between 10 and 20%. And remember, I'm not taking just eligibles here. I'm taking a population of single mothers who have high school education or below, and they may have earnings which are way above the eligibility. I'm not conditioning upon their earnings. That's an endogenous variable. I'm just taking some demographics. So these are not participation rates of eligibles, okay? They're participation rates in what I regard as a potentially eligible population of people who could, reduce their labor supply enough to become eligible. That's the idea, okay? So that's the modal, it drops way off. So for this population, I don't have any people with very high probabilities. So it's all mostly down here in this kind of region. Now, an issue here, which I realized immediately that, I haven't seen discussed a lot, which is that, the instruments here I have. What I want to do is I want to move around the participation rate here a little bit with my instruments. And I'd like to move all of them around, okay? But in fact, they don't do that. So here's a diagram which tries to illustrate that. So what I have here is, again, the predicted participation rates on the horizontal, and then up here, what I have here is all the people who are in the lowest decile, and I show in my predicted first stage regression. First of all, I show these are box plots here for the distribution of predicted probabilities within that decile, that come just from not my instruments, but all the other variables in the equation. And then I show a box plot here for the distribution of probabilities when I include my instruments. So what I'm trying to show here is how much of my instruments move around those predicted probabilities, and that's where I'm going to get all the action in my data. And so it turns out that the maximum changes here that I get, you can see comparing what my instruments do to the distribution compared to the distribution without them, around 0.3, 0.2, 0.3, 0.4, 0.5. And then it starts tailing off. And up here at 1, where I hardly have any observations, it's not doing anything. I don't have any power up there. And I don't have a whole lot of power down here either. I mean, there's a lower bound of 0 for one thing. But
the assumption is within each block it's a normal distribution. Within each block it's a normal distribution.
Yeah, it's a probit, so it's a normal. Yeah, yeah. And I've got these other variables in there, but it's a question of how those instruments move around the normal, And so, I mean, this is actually a general problem, which is that if you're trying to do what I'm trying to do here, and you're trying to get your instruments to move an endogenous dummy variable around, and you're moving the probability around, well, all CDFs, like asymptote at 0 and the asymptote at 1, and your odds, of getting an instrument which is going to move things around the tails is going to be very, very tough. And I can't do it, okay? All my action of those instruments is in the middle, and that will be reflected in my standard errors here. Okay, so here's an example. So I fit these cubic splines, and so here's one result. This is a reduced form model. And what I'm showing here is the marginal treatment effect, okay, and by F. And the blue line is my estimate, okay? And, if you want to know the details, cubic spline, you have to set these knots, I'd set them over percentile points. And so you start off with a huge number down here. This is like minus 60. And it goes up, which means that as you increase the fraction of the population who's on the program, the labor supply response falls. Okay, the marginal treatment effect falls. So for the first 10%, have a labor supply response where average about 50. The next 10%, have a response around 40 or 30, and then you get up here, and eventually it becomes I'm not constraining this at all. So it does actually go into the positive region. And I have a 95% confidence interval here, so nothing up here is significant. And I've actually drawn dotted lines to show you where the significant region is. And I'm getting significant effects only between around 0.05 and 0.21 here. It's where the 95% confidence interval does not include 0. Okay, and that's the region. But it's very clear the sign, okay, which is, and this kind of answers the question in reduced form, which is that, at least for this program, as those fixed costs moved around and say they fell and you were bringing more people on the program, the labor supply response was getting smaller and smaller. The people who came on first are the people who had the largest labor supply reductions. The people who came on later had smaller ones. So that's kind of that answers the question, okay? And I have a lot of other splines here. They all show this slope, okay? And I can add more nonlinearities here. It just doesn't change the overall picture. So I have a table here which shows how huge those differences are by the observables, okay? And so some people have like massive, reductions, and other people have smaller ones. Those coefficients on those variables, whether it be age, education, race, or non-labor income, or the G, were very, very significant. And I have some kind of theoretical explanations for all these, which I don't have time to. Okay, so the structural model. So I'm out of time. So let me just spend 5 minutes on what I'm in the process of doing. Okay. Okay, 1 minute. So make that 1 minute. So so all I want to do here is set up a utility function there, and I want to let some of the parameters of the utility function be heterogeneous. It's not it's not really all that complicated. So here's an illustration. Okay, take my Keen-Moffitt utility function, which has its pros and cons, but it's a quadratic translog. Mike and I had a lot of interactions between H, but it's a second order Taylor series approximation, and I have, of course, the P here. What Mike and I did was just allow one parameter to be heterogeneous, and this is the marginal utility, marginal disutility of H, so you let that have a distribution of the population. You've got income, you've got the benefit. I'm going to let H take on 3 values, so you're going to work either not at all, part-time, or full-time. And so you've got 6 choices here. You can evaluate the utility of each. You could either be one of the 3 hours or on or off. So you've got 6 utilities. You pick the maximum, you know. So so only thing I need to do is to allow a distribution of alpha, and I'm going to let it be logit. And right in here, I have the budget constraint variables, but I'm going to put in that G of F, that old. This is where the alpha goes in. I'm going to put in whether or not the fraction of the population that's on the program affects the CDF of alpha. In other words, and that's what we choose here. You know, which of the alternatives you choose depends upon alpha. It's a classic kind of segmented model where if you have a high alpha, you know, you're not going to participate. Low alpha, you will. If you have, high alpha, you'll be full-time. Low alpha is 0. Alpha in the middle. So I just let that distribution be a function of whether you participate or not. And I estimate this actually in the same way I estimated the other conditional mean function. The conditional mean function is a weighted average of your 20 and 40. There's a mistake here. It's a conditional mean. This shouldn't be a. No, that's right. That's right. So if you're off the program, the weighted average of the 20s and 40s times the probability that you're there, and then the participation rate times the change, which is basically a weighted average of the probability that more people end up at 20, or fewer end up at 20, or more people end up at 40, or less than will end up at 40. And these things are all just logit probabilities. So I actually estimate this by nonlinear least squares. I just plug in these predicted, it's a nonlinear function of the parameters with all these weights on the 20 and 40 as a function of the distribution of those alphas. And what do you get? Well, the only thing I'm estimating here is alpha. And first of all, for the reduced form marginal treatment effect here, I get exactly the same thing, which is that although here, see, it's entering through a structural model, that as there are more people on the program, it affects those probabilities through the logit transformation. And then here, I only have one really elasticity to show here is the wage elasticity. The question now is, so this is an example, as you expand the program and bring people more on, are the people who come in have lower or higher wage elasticities than the people who are already in? So that's what you can do here. And you can see that they fall, which is to say you're bringing in people with lower and lower wage elasticities as you expand the program, which is consistent with the idea of bringing in people who have lower and lower labor supply responses to the program, although in a structural model. So there's more, obviously, to do here, but I'm out of time. So,
yeah.
So
thanks for that. Fantastic.
Okay.
Any burning question? Otherwise, thanks very much. We'll go for coffee and back for Nettie. Thank you.
Okay.